Hello, everybody. Welcome to another Gazebo Community meeting. And let me start by sharing the screen as usual. Well, I'll do the entire screen. Let's do this. About that. This is the agenda for today's meeting. So we're gonna start as usual with the announcements. I'm gonna follow the same approach as I did last time. So I'll reuse the slides that we presented in the last meeting with the technical community meeting, and then we'll transition to the invited talk. So Pedro Victor will show us his approach for simulating Micromouse contests using different simulations, and Gazebo among them. And then we'll have plenty of time for questions if there's any interest in asking any of us questions. So let's start with the news, with the updates. These are some roadmap updates that we have scheduled for the next release, Jerry, that's happening in September. So one of the items is the migration from Qt5 to Qt6. So this is all completed. We might find issues or specific issues while we test simulation and play with different things, but the bulk of it's already completed, thanks to mostly to Ian, Michael, and Alicia. It's a bit slow, sorry. The next one is about Zeno. This is another item from the roadmap. We are updating the underlying middleware library from Easy Transport. As you can see, part number 1, part number 2, and part number 3 have been merged already. And then my next focus is on part number 4. It's already open for review, but I'm still working on it because I need to hide some Zeno references from public headers. Another thing that's already almost complete, or complete, I'd say, is that all the CI support that we need to make sure that when, just to confirm that things are working in CI and things like that. So we created a bunch of different jobs supporting different platforms and stuff. So we also think that we are on track for completing this before the Jerry release. Another item from the roadmap is touching how the Gazebo or Gazebo related command line executables are implemented. So we used to have, or we have right now, the GC commands based on Ruby. This has a few issues. It's relatively hard to debug with GDB. Ruby is not available in all the platforms, and we started this work to separate the binaries into, or these commands into its own standalone binaries. Most of them are completed, if not all at this point. Perhaps it's the format. I don't quite remember right now if it's or not, but the bulk of it was happening in Gazebo, and that one has been completed. So kudos here to Sarab and Jose for the help. And this is another thing that's been ongoing during the last weeks. Support for Bazel for all the Gazebo libraries is also in the roadmap. And the idea here is to migrate all the legacy Bazel work that we had into Bazel mode. And this is a work that Ian and Shamik has started, free image. And the problem with this is that we not only need to migrate most of our repos, we also need to migrate like recursively all the dependencies are affected. So it's very tricky and large. But the work has started. Free image and assemp are now migrated, and then there was some discussion, and then we decided that for refactoring GC Common, we decided to skip some of the dependencies like GDAL and FFmpeg, just to simplify the things. And then we refactor in GC Common to build without these dependencies. And this is also some ongoing work. Another item that's very hot because it's just very recently was completed is the removal of the version numbers from package names. This is again thanks to Steve for most of the work, and other people are contributing here, but most of it was Steve. And you can see a few examples of how things were I guess referenced in CMake, Python, or package XMLs. You know, from I guess historically until the next release that we're gonna have. So you can see that every find package that you can find, or every include in a reference. Sorry, every CMake reference to link against the library has the version number. When you're working on Python, if you're using one of the Python wrappers, the import also contains the major version. In the package XML, you also need to specify the major version. So it is okay, but every time that we need to do a release, there's a lot of churn, a lot of friction that we need to bump, a lot of work, and also for the users. So the users need to go through all this elements CMake, Python references, packages.xml, and then update that, change GCmath with GCmath 8 with GCmath 9, for example. In Jetty and later, this is going to be how it's looking. So when you call find package, it's going to be just GCmath. Same thing when you're linking. Same thing when you're importing from Python. There's not going to be major version, or also from your package.xml. As usual, nothing is for free. So the trade-off here is that future versions of Gazebo are not going to be side-by-side installable. There's always the ability to compile this from source in your own workspace, and that way you can have multiple versions, but you cannot, I guess, install binaries side-by-side as before. But we think it's totally worth it. We think, especially for the users that are going to have less things to change when they upgrade. Another set of updates, some of them I mentioned them in the previous community meeting, so this is just an update, but we were also exploring this auto-release idea for the Gazebo libraries, and right now we're prototyping that every PR will contain change logs and a way to bump the version of that library. For the sake of time, I won't enter into a lot of details, but there's some ideas and some prototypes that we're gonna start creating, starting in GC Transport, and then when things are tested, if we're happy with it, we'll propagate those into all the libraries. With in the long run, what we are trying to do is reduce the manual steps needed to release a library, and then eventually the idea is just try to do releases automatically every certain period of time. Jenkins Windows agents have been also updated. There's another update here because we experienced an issue with the GC Fuel server some weeks ago. And then we decided to create a group of volunteers taking care of these websites and these services, GC Fuel, both the server and the GUI, SD format, and we call them the emergency plan. It's like a first group of responders when one of these websites are down. And our plan is to create a playbook where we clearly identify what are the credentials that this group of people needs to have, making sure that all of them have them. And then this playbook will contain also the set of steps and the set of common problems that these websites had in the past. And that way it will be easier to revive the website and resurrect everything, and also we'll try to keep a log of things that happen over time. With the idea that things will be back to normal faster, and also we know exactly the set of steps that need to happen. A few other things that happen in the Gazebo community, mostly within PMC members, is that the Roscon, I guess, date for proposals, or the deadline for proposals is next week. So we discussed a few ideas for potential proposals, and there are a few ideas, and I think the people involved in every idea is now self-organized, working mostly this week because the deadline is Tuesday-ish, and finishing the proposals this week. Another similar idea happened with the OSRA proposal for funding project ideas. So we organized ourselves. We had a meeting where we discussed, brainstorm a few ideas. There was something similar to a voting, where all the ideas are now under a poll where you can vote, and then probably in the next Gazebo community meeting, in the next Gazebo PMC meeting, Monday, we'll go over the results and the same thing, organize ourselves to create a proposal or a few proposals with the most voted and the ones that make most sense. GSOC is ongoing. The two projects that we have are happening. And I think that's all. That's all from me. So let me go back to here. Oh, what happened? No, what happened here? The community agenda. Are you guys still there, first of all?
You're here.
Okay. For a second, I thought that I was alone. I don't know what happened with the agenda here. Is there something? Oh. Okay. Well, let me do it the other way. So while we recover the agenda, I think it's time for our invited guests. So it is my pleasure to introduce Pedro Victor Fontoura Zawadniak. I'm sure I pronounced it perfectly, from Analog Devices. And Pedro was nice enough to talk about his work using different simulations, including Gazebo, for simulating Micromouse contests. So I'm sure he'll go over all the details. Thanks for volunteering, and it's all yours, Pedro.
You got the name just right. Thank you for the introduction, Carlos, and thanks everybody in the team for the invitation and the opportunity. Just let me start sharing my screen. I need to find where this is. Okay. Entire screen. So you should be seeing my screen now. I hope that's the case.
Yes.
Okay. So yeah, I'm going to present my work. I call it Ratada. This is basically, it's a set of plugins for Gazebo that allows the user to simulate a Micromouse contest. And this is a screenshot of how the simulation looks like right now. And hopefully by the end of the presentation, you'll be able to understand what is it that you're looking at here, and it'll make sense. So about me, Pedro Victor. Currently, I'm working on as a software engineer at Analog Devices, doing embedded software, specifically embedded tools for embedded software development. I studied at Federal University of Technology, Paraná, and Polytechnic Institute of Bragança. And the reason I'm making sure to mention that is because let's say the origin of this work of the simulator was the final project that I did for my master's, which is a project of a similar idea. It was also to simulate Micromouse contests, but it was using Unity, like Unity as in the game development engine. Um, so this is, let's say, a respin of the project now using open source things in general. So Gazebo, much better integration with ROS, and everything else that comes with having like a proper robotics environment. Just disclaimer, this is my own work, not affiliated with the universities or where I work. So that's it. So what is Micromouse? And you tell me if it's okay or not. I have a few short YouTube videos that I wanted to share just to show what is it that I'm talking about. If there's a problem with showing that for the recording or something, just let me know. But basically, it's a robotics or event competition. This is something that happens in real life. So real life first, let's say. And it's for autonomous robots that compete on solving mazes. Many of those events are sponsored by universities and also IEEE. And just to get a nice understanding of what it is I'm talking about, I have two short clips that I want to share. If I can find here. So we're just gonna wait a little bit here. This is the part where it's like a first like a run will actually start, and I'll be able to explain. So here you can see the contestant. He has his robot in his hand. He's putting it at a predetermined position on the maze, and that's, let's say, his first run through the maze. So this speed that you see his robot going, it's a slow speed, and you're going to see how it is in comparison with an actual fast speed. And the idea is that at first the robot is able to just go around the maze and recognize the environment, so it can know where the walls are. I should have said it in the beginning, but it starts, the robot doesn't know anything. It knows he's starting at the bottom left corner, depending on the perspective, and that he has to find a goal at the center, but he doesn't know where the walls are or any other information about the maze. So what you're seeing now is like after the initial run or initial runs, he actually did a speed run through the maze, and that's like his let's say the time he scored in the competition. Same things happens here, like it's pretty usual. So that's about it from this video. And there's another one which I want to share. Now, this competition, it's called Micromouse, and there's like, let's say, a spin of the competition, which, this one might also be classic Micromouse at this point. There's also the half-sized Micromouse, which is an arena of the same physical size, but instead of having 16 by 16 grid of cells, it's 32 by 32. So everything in half, let's say, except for the speed of the robots. As you're gonna see, this was the winner of this this particular event. He has just placed his robot on the starting cell here, and I'm just gonna let the video play and try to find where his robot goes. No, he hasn't yet, but he's about to. So these robots, they go really fast. That's the main point. I haven't been involved into these competitions really. Like my involvement with it was making the simulator for the finals project, and now with the simulation in Gazebo, but I haven't actually competed on it. But as I hear, the limiting factor or the bottleneck where people can get the improvement now is not in the exploration of the maze. So it's not the algorithms to first explore the maze and then to decide on what the fastest path is, but instead it's in controlling the robot. So it's actually making sure you can perform whatever path you decided to as fast as possible with taking as many shortcuts as possible. So that's for context. This is the simulation that I wanted to be able to simulate in Gazebo. So now, having this overview, I'll just talk a little bit about the rules. So because this is also plays a part into what the simulation is showing. So the maze is a 16 by 16 grid. There are start and goal cells. They are known beforehand where they are physically. There's more than one solution to the maze, so there are multiple paths you can choose. Some paths may have like longer straights. Some paths have maybe like shorter, but they have more turns. And the maze is designed to make sure that trivial strategies, such as just following the contours of the maze, they do not work. Historically, funnily enough, it actually did work. So I'll leave some links for reference. But in the first ever competition, it was called, as far as I could find anyway, the Amazing Micromouse. Actually, the winners were just they managed to just follow a wall when they would reach the end. So also, the robot is autonomous, so there's no communicating to it or from it during the competition. And the robot dimensions are limited. Like they need to fit into the cells. I think there's a slightly smaller threshold, but they're not limited in height. So it has been found that some people would have just arms that extend and have a camera where they can actually just take a photo and process the maze. So there's room for some non-conventional approaches, let's say. Regarding the contest rules, so the exact rules, they vary between competition and competition, but so I'm going to be a bit vague here on purpose. But in general, the competitors are allowed multiple runs. As you saw in the video, like the first time it goes slow so that it can actually just explore the maze and make sure he gets the wall positions right. And then subsequent runs are the runs that are actually timed for the purpose of like having a score and comparing for who's the winner and all that. And then after all the runs are performed, again, not talking about how many or how long they have to do it. I'm not sure, and I know it changes a bit. But the robot with the single fastest run is the one who wins. So now demo time. I have a virtual machine here running Ubuntu with Gazebo. If this doesn't work, I do have a backup video, but it has all the reasons in the world to actually work. So let's give it a try. So like I have cloned the repository that's on GitHub. I'll go through the repository in a bit. But after you clone that, you make sure just run the install scripts. You can launch Gazebo with there's a Rust2 launch script that launches Gazebo and the required plugins. So what we're looking at here is this is basically the plugin that the user is going to interact with. It allows you to select a maze. So let's select a maze. And this one I got here already pre-prepared here for demonstration. You select a maze, and I'm going to show how the format looks like, but then you select a robot, can be URDF or SDF. Then you can basically adjust where your robot is going to spawn. So it's going to be in the initial cell, but you can say, hey, I need this to be a little bit higher, actually, because otherwise it's going to spawn at z equals 0, and that's just going to be cut by the actual floor. And then from here, I can just load to the simulation. And here we are. So this is the maze that I chose. Here's the robot at the corner. And actually, to better visualize what the robot is doing, there's a couple other plugins that I want to add here. Tree LiDAR. And this is specifically because this robot that I selected has those sensors. I'm going to talk a little bit about that. So I loaded, I have everything configured here. I can start the simulation. And I can press start. We just send a message to the Rust2 node that, hey, it's okay, you can start doing your thing. So you can see it doesn't run very smoothly in this machine. The only time I run this was in this virtual machine, so I never tried any other setup, but it's about 60% of real time. And you can see this robot in particular, it's going to be slowly but surely going to explore and makes its way to the center. And when it reaches the center, it goes back to the beginning and does that in a loop. As you can see, there are three rays coming out of coming out of the robot. It's pretty standard for the robots to have time of flight sensors. So I think some of them use time of flight sensors in the rear of the robot as well. But here I have two diagonal ones and one straight to the front. And also there's a plugin simulating um, wheel encoders. So it's as if you have wheel encoders positioned at the DC motor shafts. The, the DC motor itself is not actually being simulated, but it's attached to the wheels. And from the wheels, you can tell the plugin, hey, actually consider this being a motor with this such a gear ratio, and then it just gives you the ticks as an incremental encoder. So here you can see it unfortunately misses the actual center, but he's going to come back. He just decided to explore like forward here, but there was a wall, and there was a wall here. So now he's going to come back and actually find the center. Just for completeness, I'll just let him him reach there, and then I'll go back to the presentation. And the robot has this green thing here. It's actually an additional block that I put just to have weight on the back of the robot. Otherwise, he wouldn't like balance properly. So yellow wheels, red body, and green, whatever it is that you want. So yeah, that's it for the demonstration. I'm going to close here. I can go back to this later on. So now I'll just talk a little bit about this is the beginning, about the origins of Ratada. So I mentioned that it was a university project. I call it Unimouse Sim. In the presentation here, I left some links about some related publications and the actual project. The idea, as I said, was very similar. We wanted to have an environment that you could simulate Micromouse. But in particular, I wanted it to be hardware in the loop. So I don't want the software to be actually running on the PC. I want you to program actual hardware that could be in the Micromouse and use that to talk to the simulation. So that maybe in the future, when somebody is actually taking that, it would be possible to, not easily, I'm sure, but it should be more straightforward to port that to an actual robot. In the Unimouse sim, the simulator in Unity case, I was sending commands through USB and UART. With Gazebo, I haven't demonstrated that, but it's actually much easier to do that as long as your hardware has support for ROS2. That's basically out of the box included in the simulator. So what were my goals here? What did I want to achieve? First thing, I wanted to hide internals, Gazebo internals from the user. So I showed like you get a plugin. From the plugin, that's how you select your maze, you select your robot, adjust and do everything that you need. I didn't want somebody to have to take their robot SDF files and then edit the world files and put it there and put the robot with a particular name because that's the name that the simulator expects. So I wanted to just really encapsulate all of that and just say, hey, you have your files. Okay, just I can load them and your simulation can run. Of course, other than this, the user would have to have the actual ROS2 node that's controlling the robot. But in terms of how he interacts with the simulator interface, that's pretty much covered by the plugin. I wanted actually multiple mazes to choose from. And actually, I'll actually show this now. Where is it? This one. So there's a person called Peter Harrison. I think I got his name right. So he maintains this repository of maze files basically, and he also authors. Peter Harrison, here he is, and he also authors this Micromouse online page. It is an invaluable resource for everything Micromouse, so building the actual robots, algorithms, and a lot of stuff. And I leverage his repository of maze files to to basically be able to provide them or to import them into the simulation. So the one that I used was this one. It's a text file, right? So walls are ASCII, everything is ASCII characters. As long as you have this, you can just select the file and the backend. So you select it in the GUI sends it as a message to a backend plugin, a system plugin running in Gazebo, and it processes everything here and creates all the walls. So you see, there's a lot of mazes here from a lot of competitions, historical competitions like that actually happened. There's some test mazes. This was a very good find and very useful for just enabling the simulator. Because if you want, the user wants to add their own maze, here they have a pretty much standardized format that they can just edit and do their own thing. Let me try to find how do I share, but not. I don't know how to not go back to the beginning, but that's fine. The other things I wanted to do, so the simulator should track the robot solve time. I actually do that, but I don't have a visual representation yet. So when the robot finishes his lap or his run, there's a message being published, but I don't have a visualization for that. Simulator allows you to reposition the robot, and this is true for two things. First, you want to fine-tune the position at the very start of the competition when you place it in the starting cell. But also your robot might crash. And the rules in the competition, they cover this case, that there's a protocol of what you can do. You may get penalized, I'm not sure, but you go in there and you take the robot and put it back in the beginning. So I wanted this to be covered in the simulation as well. And as long as your ROS2 node or your thing that is controlling the robot can handle a crash and knows how to do that, there is a button in the simulation that just resets it back to the original cell. I also wanted to import the robot from URDF or SDF. And this basically, I didn't have to do any development here. It was already using the functions within Gazebo. ROS2 integration, of course, that's also out of the box, pretty much available. Just need to do the mapping from Gazebo commands to ROS2 commands, and a simple application, which is what you just saw being running in the simulator. Here's just a closer look in the GUI plugin. So this had select maze files, robot files. You can adjust, load the objects, start the simulation, make sure it's not stopped, and then just say start, and your ROS2 node can process the start command and actually start running. From the user perspective, this is the simulator. This is what they look and say, oh yeah, the simulator is here. Because the other stuff are, there's a backend plugin and an additional wheel encoder plugin that I put into the sample robot. Oh yeah, maze file format, I've been through this, all ASCII. There's start and goal cells as well. That's very handy for what the simulator does. In the classic version of Micromouse, the goal is always in the center 4 cells, and the start is always in the bottom left. But if you take the half-size Micromouse, I think the start is also fixed at one of the extremes of the maze, but the goal may vary. So they just say, hey, for this competition, the goal is going to be right here. So it was nice to just be able to take this information already in the maze files and plug it in onto the simulation. Because you need to track the solve times. You need to know where the goal is to track if the goal was reached. So now, system plugin. So this picture is not very good to demonstrate what I'm talking about, but I'll just explain. So once you import the maze, you can inspect the actual maze in the entity tree view here. And here I have selected one arbitrary view, visual 57, and it's actually from this big wall here. I'm not sure you can see yeah, okay, it's red and red didn't help too much, but it's this wall. I just wanted to demonstrate there's a nice optimization, I think, that I implemented, which did help a lot with the simulation time, which was to, so I'm not just reading the file and saying, oh, there's a wall here, create a wall object here. Oh, there's another wall, create another wall object. I'm actually joining the walls that are adjacent into a single object. So that it manages to, I forgot the exact numbers now, but I think it managed to reduce the object count from the maze alone, from like, I don't know, 600 walls to usually around 150, 200 walls. And they noticed that this reduction did help a lot with the simulation time. Again, I only tested it on the virtual machine, not sure how it goes in native or in Windows. For the encoder system plugin, I basically followed the structure of other plugins already in the Gazebo repository. What I wanted to simulate was an incremental encoder. So incremental encoders is basically, it tells you how many positions, and each position has it corresponds to a determined angle. How many positions did your wheel advance since the last simulation step? And then from knowing how this number, then your code would be responsible for processing, hey, this many ticks or this many delta positions corresponds to this much angle, and this much angle corresponds to this much displacement of the actual robot. You know the wheel sizes and you know everything. This is the approach that I had taken for the simulator in Unity without having Gazebo. So as you can tell, this, and I can tell very well because I'm not too familiar with Rust2, to be honest. But it's not making use of what the features that Rust2 provides you. So I'm giving you ticks, which you have to translate on your own to a displacement of the robot. But it could be making use, I'm sure, of a lot of things that are already present in Rust2. So if you want to build your own robot and just take that as just treat a plugin that tells you the distance directly and have this be an input to that plugin instead, of course, that's viable. Now, design choices. So you launch the simulator, there's just a blank screen there, and then you select the maze files, and then they get created. So everything is there in this sense is happening at runtime. Whether this is a good approach or not, debatable. I'm not too sold on the idea, but this is the best that I could find. Considering that, I will just read through the bullet points here. The alternative would be to provide a script that generates the SDF road from a maze file input. So I want the user to be free to choose what maze they're simulating. And the maze is an SDF element in the SDF road. So how does it go there? How does it get integrated into the maze? My approach was to do everything at runtime. Just say send like a object create command. I forgot how it's called, but the alternative to that is you have to either have a script that will edit the file and then you launch the road, whatever. It's possible to do in other ways, but I just found it easier. And then let's say the user decides that, oh, now I have a different robot, it uses different sensors. Then they have to go and edit the SDF file, rerun the generation script because it changed. If I just do it at runtime, there doesn't seem to be like a huge penalty for that. And then everything is already taken care of. Now, the other thing is importing the robot at runtime. Maybe it's a preferred approach, or at least it takes into account some of the drawbacks from other approaches. Because if I don't select the maze file at runtime, the user would need to place the robot in an arbitrary position. Because if it's not at runtime, it was already in the SDF. So the road has already needs to reflect the exact start position plus adjustments of the robot. And then it would also have to inform the name somehow to the plugin because I need to know what object is the robot so I can track the lap time. And if I do the approach that I took, if the plugin creates the robot, it knows where it created it. It doesn't care, but you can select it there. And it knows what the object name is because it created it. So that's also a known issue with this approach. Future development, and there's a lot of things that can be done. So code can be improved. I mentioned like everything is being done at runtime, but currently the way that I'm processing the maze is just iterate through the contents of the text file, and while you're doing it, go start creating the objects. A better approach would be to have an actual internal representation of the maze. Then maybe the user can even edit the maze from the interface. there could be more robust go and start detection. I didn't go into much detail of how that's actually done, but currently it takes the center of the robot object and then the center of each start or go cell. And if it's within a certain thresholds, it just considers that the robot is now in this the cell that it's testing for. Ideally, like I would actually like to have like a bounding box on the robot and a bounding box on all the Google cells, so that you can actually see, okay, the robot is fully within the cell, and that's how it's done in the real competition. But I just found that perfect would be the enemy of actually getting things done. So I said, okay, no, this is good enough for now. I found some issues with the GUI plugin, the size and crop. Sometimes, and I don't know what times, I couldn't actually diagnose what happened, but it cuts out a portion of the plugin. It could be related to the resolution of the virtual machine. I'm not sure. So there's certainly things that can improve there. As I mentioned, I want to visually display the lap time information, maybe track what's your 3 best lap times or something like that. And also have more sample robots and sample applications. As I said, this one is one that I had done a bit before. It wasn't using ROS2, and it's taking a very not ROS2-like approach, let's say. But it works. But of course, we can have more sample applications that actually, and maybe like more robots with cameras, so that you can actually use all the navigation functionality from us. And currently, ROS2 is used merely as a message passing system. So I have a ROS2 node processing all the inputs, and those inputs, as I mentioned, are the encoder ticks and the distance that each of the time of flight sensors have measured. So the ROS2 node is keeping track of where it thinks the robot is and making all the adjustments. So it's basically processing the raw data from every sensor and sending commands to the robot in the same manner. Certainly could be better, or let's say make better use of the ROS2 functionality. Very crucial point, if there was to actually get some contribution from other people, is repository organization. Right now, I'll actually go back here and show what the repository is looking like. So I have a bunch of Gazebo plugins, and I have one ROS2 node that actually is the sample application that I mentioned. Gazebo workspace, there's some scripts for building everything, but there's an encoder sensor system, Micromouse. This is the GUI, and this is the backend of the system plugin. And those two are just the encoder sensors, system plugins. For the ROS2, there's a source file here for a bunch of things. I didn't even actually look at this. I reused a lot of the things that I had done 5 years ago. But there's like URDF files, everything. Here is nice. Here it's nice as a simple application. But the problem the thing that can be really improved is this maybe shouldn't be all in the same repository. Even if we can take into account what was announced today of changes for new Gazebo versions. How do I update this and make sure that I have a version that can run on Gazebo Harmonic and then one on, I forgot what the J letter was. So right now there's not a good way. Is the good way to do this just to have each one in a separate repository and then a different branch for each version? I don't know. I haven't thought about this. So, but any consideration that would be welcome. And also creating collaboration guidelines, like, or just having maybe a vision of what do I want to work at, what contributions I would be very happy to take here. And this is not mentioned currently anywhere, or it haven't been decided really. So this was about the simulator itself. Now I just have a few feedback or not even feedback, but just saying how my experience with Gazebo was. Taking into account that my prior experience with any kind of 3D tools that I'm doing some kind of simulation was with Unity. Managing the sensor insertion, deletion was a bit of a pain. So the plugin keeps track of whether the SDF was modified and has to to create and delete. I mean, you can do it however you want, but that's the approach taken. If it was, I don't have a suggestion here, so it's kind of a blank statement, but I hope it can change at some point. I don't know. I don't have any way to suggest. It wasn't very clear to find out what API I could use to import the objects. So I'm talking about. I found an API that processes URDF and SDF. It worked perfectly, but I did have to dig a lot into the source code to find it. And it was not clear how I could achieve the same functionality as the right-click menu for the places. And I'll actually just show what I mean here. If I just launch very quick. So I'm talking about this interface here where you can just click here and place. I could use this to replace the robot in the starting cell. Obviously, it's implemented and obviously it works, but I don't know if it's exposed to other plugins to make use of the same calculations that it does. Here I just left some links for Micromouse rules if anybody's interested in looking that up, and a bunch of Micromouse videos. This first one, if I'm not mistaken, is one by Veritasium, and the video is incredibly good. It goes through the history and it goes through strategies for actually solving the maze. But yeah, a bunch of other links to Micromouse related stuff here. And that's me. So thanks everybody for the opportunity, and hope that was a good presentation. I'm trying to look for the screen here.
Thanks, Pedro. Thanks for the presentation. Yeah, that was very nice. It's always a pleasure to see people using Gazebo in very different ways, but making use of all the different creating plugins, creating worlds, creating models. So putting all this together is always very refreshing and see the final application. So very nice. I think I saw Steve, probably a question.
Yeah, can you bring up this slide again with kind of the feedback about Gazebo? I had a question about adding and deleting sensors, just what you were meant specifically.
Sure. So where is it? No.
Towards the end, yeah. I think that second bullet point, managing sensor insertion deletion manually is a pain. Are you referring to the sensor systems, the sensor plugins?
Yes. Yeah. So I can actually. I think I can find it quickly here on what I mean in the source code actually. So if we take the same approach that like it's taken for the other Gazebo plugins, I think there was an STD. Yeah, like it keeps the sensor maps like in a map, and I think it has to manage when it's removed or added to the simulation. And I forgot to mention, I did implement this as a custom plugin. I haven't tried to implement it as like the same way that the other sensors are already implemented. So you can just select as IMU or all the other options. I forgot which one they are. So maybe it's easier if I do it differently. But this is what I came across when I was following both the. I think there was a tutorial page just explaining how to implement your own, and this is also how I saw that the others being implemented. And what I mean is, if all I want to do is actually just provide a plugin. I would like it to not be required of me to manage them in the map here and just add and remove them manually. This is basically what I meant. Or also, I can say that I wasn't expecting when I started creating the plugin, I didn't expect that I would need to do this. I guess this is where it really stems from what I wrote.
So maybe in GZSim, a sensor system is different than what a sensor plugin was like in Gazebo Classic?
Yeah, so I haven't looked into Gazebo Classic. I know it changed a lot, but I have absolutely no idea how it looks like.
Okay.
But this is all for post-ignition Gazebo. This is in harmonic.
Yeah. Okay. Yeah, I'm. Yeah, I think if you have a feature request, or if you want to describe what you would like to do and how it could be easier, we can discuss that in a GitHub issue.
Sure.
Yeah.
I have another. Well, any other questions for Pedro? I have some questions. You mentioned that the control part is probably like the key aspect of these competitions. And I'm assuming because in the real world there are certain physics things like wheel slips and stuff like that. Did you consider to simulate that in the simulation, or maybe you're already doing it?
I didn't know, but that you're perfectly right. I think one of the things is wheel slip. That is one of the major problems. And I know some robots actually use vacuums to hold them closer to the floor and not let the wheel slip. I don't have any ongoing work on this, but that's definitely something that would be interesting to have.
There's, if I'm not wrong, there's an existing system in Gazebo also for implementing wheel slip. So
as also one of the what makes it also hard to simulate that is because you also then have to have an application that processes all that information. And as you saw, like from the demonstration, the robot that I implement is actually very simple. Like it doesn't do any kind of fancy turns and all that. But,
yeah.
So,
No,
but if there's anybody who knows how to do that, certainly that would be very valuable.
I think it's always, in my opinion, it's always nice to have a solution that's perfect, right? That doesn't have noise, doesn't add any of the slips and stuff like that, wheel slips and things, because you can test if your code is correct, right? There's not gonna be under perfect conditions, of course. And then when it's all fine-tuned, then you can start complicating the simulations to actually mimic what happens in the real world. But yeah, I think it's good. Another question that came to my mind is a bit random, but is there any competition that's, because this is pretty much like 2D, right? It's all on a plane, but is there anything similar on 3D with slopes, or that makes things even more interesting? I know you might have to change things, but
I know there are some robotics competitions that do that. I don't know the name off the top of my head, but they're not Micromouse anyway, but there's some competitions. I know they're simulating like if the robot was in a factory, so it has to go from one place to the other, and these places include like slopes and a lot of things. But I wouldn't be too familiar with those.
yeah. I think the format of the mazes and everything had to change probably, so it would be a big change. But out of curiosity, if you were thinking about that. About the RIP organization that you touched, most of the conventions that we follow, well, the ROS ecosystem follows the convention of name branches. So if your system is compatible with Jassy, then you should go on a branch named Jassy. In Gazebo, we follow a similar approach with branches for our different stable versions, but typically we use the version numbers. So it's going to be like GSM5, GSM6, so you could do something similar to that. But I'd say we use branches typically to host like the different versions. So it's just as
No, that's interesting. Appreciate the comment. Yeah, it's something I might look into the short future or near future.
All right. Do we have more questions for Pedro? Otherwise, I'd like to congratulate again for your talk. thanks again for volunteering, for giving us your thoughts about Gazebo, for showing up your work, and happy to see you around in the future.
Sure. Thank you very much.
And thanks, everybody.
Thanks for having me.
Ciao, ciao.